ఇలా పెడుతున్నా తీసుకొని వాచ్.
மேம் உள்ள வந்துட்டேன் மேம்.
So good evening, all gathered here. I'm all welcoming for this second day session of our ATAL faculty development program on data science. I feel immense pleasure in welcoming our department faculty, Mrs. Pandishwari Madam, to welcome the gathering. Welcome you, ma'am.
Well, a very good evening to everyone. It's my great pleasure to. Ma'am, it's audible, ma'am.
Yes, ma'am. You proceed, ma'am.
Okay.
Pandishwari Madam, you can continue.
Okay, ma'am. Okay, ma'am. A very good evening to everyone. It's my great pleasure to welcome you all to the second day of AISTC ATAL sponsored online faculty development program on data-driven model, empowering academicians for the data science era, organized by the Department of Computer Application, Nada Saraswati College of Arts and Science Autonomous Training. I welcome our respected Secretary Sir, Principal Madam, Head of the Department, participants from the various institutions. I extend a warm welcome to our resource person, Dr. P. Jayagauri Ma'am, Principal, Sudarshan College of Arts and Science, Pudukkottai, who will enlighten us on the topic Mathematics and Statistics for Data Science. I welcome you, ma'am.
Thank you, Pa.
Doctor is there. Ma'am,
Shall I start the session, Ma?
ma'am, I read a profile, ma'am.
Okay. Do it.
Okay, ma'am. Dr. P. Jayagauri ma'am is the principal and head of Department of Maths at Sudarshan College of Arts and Science, Pudukkottai. She holds a PhD in mathematics from Anna University and has over the 22 years of teaching experience. Her research focuses on fuzzy system, computer network, and operation research. She has published 30 international journal papers, attended organized several conferences, and authored 2 books on engineering mathematics. She received the INSCS Research Excellence Award at 2021 and she is a lifetime membership of Indian Society of Technical Education. I welcome you, ma'am. Now the session is yours. Thank you, ma'am.
Thank you, Ma. Very good evening to all. It's truly an honor and pleasure to be here today as a part of this faculty development program. At the outset, I would like to thank the management and the organizer for giving me this wonderful opportunity to interact with such as enthusiastic group of academicians. Faculty development programs like this one play a vital role in enhancing our professionals' competence and keeping us aligned with the latest trends in teaching, research, and innovation. As educators, we are lifelong learners, isn't it? And every such gathering gives us a chance to reflect, refresh, and reinvent ourselves for the benefits of our students and institution. In today's session, I am going to take about mathematics and statistics for data science. Nowadays, the people entering into mathematics group is very low. At that time, I am very happy to initiate this faculty development program. Your data science is correlated with mathematics. It will be very helpful to the student society. I hope this session will be interactive, thoughts provoking, and useful to you. Once again, I expressed my gratitude to the organizer for this invitation. Thank you, ma'am.
Thank you, ma'am.
Shall I share the
Yes, ma'am. We can start, ma'am.
Is it visible, ma?
Yes, ma'am.
Okay. Shall I start the session?
Yes, ma'am.
Is my screen is sharing, ma?
Yes, ma'am. Your screen is visible.
Okay. Thank you. Thanks a lot. See, I'm going to take the topic mathematics and statistics for data science. I hope this faculty development programs is about data science because computer science people organized this. Actually, mathematics is a queen of science. Mathematics is a basic of everything. So now I am very happy to here to explain how this concept, mathematics and statistics, are correlated with computer science, especially in data science. So we are going to see the basic things, fundamentals of statistics, and what are the classification of statistics, and how that that statistics is applied to your data science. Okay, so we are going to reveal all these things. Don't fear for facing failure in the first attempt, because even the successful mathematics start with zero only. So the great proverb was delivered by Dr. APJ Abdul Kalam. So what is maths? Maths is a science and study of quality, numbers, formulas, and related structures, shapes, space, and change. So these are all the few words I put up here. May I know, do you have any idea about what is the definition of mathematics?
Ma'am,
Is
excuse me,
anybody-
slide is not moving, ma'am.
Hello?
Slide is not moving, ma'am. It shows the first slide itself.
Slide is not visible.
Not moving.
Not
It is still in the slide 1.
slide 1. Oh.
You can
Now?
use the slide show, ma'am.
What about this one?
No, ma'am. Now also it is seeing only the first slide.
Okay,
Yes,
ma'am.
now it is second slide, ma'am.
Okay.
Yes, ma'am. Second slide, ma'am. It is showing.
Is it visible, ma'am? Second slide?
Second slide is visible, ma'am.
Okay, fine. What about third slide?
Still it is not there. Ma'am, you
Third
can
slide-
use the slide show, ma'am.
third slide, whether third slide is visible or not, ma'am?
No, ma'am. Now it is visible the second slide.
Second slide. Okay, what happened? But I am sharing, ma'am.
Yes, ma'am. You have shared, ma'am. Your screen is visible. But in the
Okay.
PPT slide, second slide is viewing. But you are speaking about the third slide. Now third slide is okay, ma'am.
Okay. Okay, ma'am. So I'm keeping like this. If I go to full screen, then some problem came now. Okay.
Okay, ma'am.
So
Okay, ma'am.
I keep like this. Okay.
Yes, ma'am. Okay.
Tell me, what is mathematics in your aspects? Anyone? What is the definition of mathematics from your side? Tell me. Just a few words, that's enough. Is anybody there?
Ma'am, participants, please unmute your mic and you can answer, and then please you mute yourself, ma'am.
See, we are going to discuss many things about, okay, if you are interacting means then the session will be very interesting. Okay.
Participants, please, you can unmute your mic, you can answer, and then please mute again.
Yeah, good evening, ma'am.
Yes, good evening, sir.
In my perspective, mathematics is a science or an art that can be used for solving problems.
Okay,
It
fine.
can be in some scientific way or whatever it may be the way.
Okay, fine.
But
It's nothing
methodology
but
of scientific-
solving the problems, sir.
Yeah, used for problem
Yeah.
solving.
Okay, fine.
That's nothing.
Okay, thank you.
Thank you.
Now I'm going to, here I am present a few recent application in mathematics, especially at computer science, because we are going to talk about the data science, no? So I am giving some few applications related to computer science. Okay. So algorithm and data structures, that mathematics plays a vital role. In cryptography also it plays a vital role. Data analysis, it plays a vital role. So algorithm and data structure, how that mathematics involving means. What is algorithm and data structure? As a computer science students, you are very aware about that algorithms and data structure, isn't it? Okay, so how the mathematical concept is involving here means the fundamental to the design and analysis of algorithm. For analyzing, if algorithm is given, for analyzing that algorithm, mathematics concept is needed. Okay, so for design, for making design, the
ஒரு வீடியோ எடுங்க ஒரு
Madam? Madam, you are not audible.
Not audible, ma'am.
okay. So these are all the recent application mathematics involving computer science. Next. Uma ma'am. Okay. So this is the outline of the presentation. First, I am going to give the definition of the statistics, then classification of the statistics. Here we classified statistics as descriptive type and another one is inferential. Then what is data science and application of data science. Then finally we conclude our session. Next. So what is statistics? So first, statistics is a branch of mathematics. Okay. So statistics is nothing but the collection. Okay. So what we collect. So collecting, organizing and analyzing numerical data to solve real world problems. So that is the definition of the statistics. Okay. It helps make sense of complex data through quantitative models. It plays a critical role in decision making in fields like weather forecasting, stock market analysis, insurance, and data science. Is all of them known where this statistics is applied in our real life, isn't it? So in all the real life, we need the data. Okay, we know that the politician is always give many data, isn't it? So the collections, that collection is called as statistics. Okay, we have to collecting the data in a organizing way, and the collect sometimes that collection is an organizing way is one of the statistics. Then analyzing the numerical data is also the statistics. Okay, so analyzing is applied in stock market field. Okay, collecting the data is applied in the weather forecasting fields. Okay, so these are all the real time applications. Next. Next, ma. So previous one, ma. Statistics is a branch that deals with the every aspects of the data. That is a definition of the statistics in the mathematics book. Okay, so here I am sharing this one. Statistical knowledge help to choose the proper method of collecting the data and employ those samples in the correct analysis process in order to effectively produce the result. Okay, so at finally, what is your output means we have to produce the output as a effective result will be very effectively. Okay, so that statistics help to produce the result in a effective manner. In shortly, we have to say that statistics is a crucial process which help to make the decision based on the data. Next. So what is statistics in mathematics? Again and again, the same thing. In mathematics, statistics concern the collection of data, organization, interpretation, analysis, and data presentation. So all these things are called the statistics. Next. So what is the purpose of statistics? The main purpose of using statistics is to plan the collected data in terms of experimental design and statistical analysis. Statistics is considered a mathematical science that works with numerical data. Next. So what are the real type example of statistics? So an example of statistical analysis is when we have to determine the number of people in a town who watch TV out of the total population in the town. The sample group of people is called this sample here, which is taken from the population. Okay, so from the large number of data, we have to collect something. That collection is called the statistics. Okay, here one example is given from the town. They are collecting only who watch the TV. So that people is called the samples. Okay, from the total population. Next. So what are the characteristics of statistics? Statistics are numerically expressed. So numbers involving. Okay, so number must be involving. It has an aggregate of facts. Data are collected in a systematic order. Yes, we must follow the systematic order. Then only the result will be coming. Otherwise, it won't come. Okay, it should be comparable to each other. So statistics is also used to comparing the two datas. Okay, so what is the output of first data? What is the second output of the second data? So we have to compare. From this comparison, we have to tell which one is the best. In the marketing field, we can easily say that no. If you are taking, for example, if you are taking soap, one is Margo soap and another one is Mysore sandal soap, we have to compare. So how many of them used, in which type of people used, then how much cost it occurs. Okay, so we have to compare. These are all the main questions between the usage of soap. Okay, so we have to compare the data to each other and we have to come to the conclusion. So that is a concept of the statistics. Then last one, data are collected for a planned purpose. Okay, next. So what is the importance of statistics? Okay, statistics helps in gathering information about the appropriate quantitative data. Okay, so the main purpose is a main important thing is gathering the information. Okay, gathering the information. It depicts the complex data in graphical form, tabular form, and in diagrammatic representation to understand it easily. So how that data expressed means either in graphical or in table or in diagrammatic. Okay, so it provides the exact description and a better understanding. Yeah, say in the 10th standard itself, many students are selecting the graph, no? Okay, so why they are selecting graph question? Because that is easy. That is very easy to understand, isn't it? So many of the people select the answer for table type of question, isn't it? Why they are selecting table type of question? Because that is easy. Okay, just by heart the table, then that gives the answer. So statistics is involving, statistics is giving that type of formation, that type of result, that type of procedure. Okay. Then next one, it provides the exact description and a better understanding. Yeah. So when we give the graphical notation, then all the people can easily understanding, no? So they are giving like this. It helps in designing the effective and proper planning of the statistical inquiry in any field. It gives valid inference with the reliability measure about the population parameters. Inference is nothing but the statement. So what statement it gives, what statement it gives, gives the reliability measures. So how we can say the reliability measure? We have to check whether that statement is correct or not using that data. Okay, so in the next topic I will explain how to validate one statement. Okay, then last one, it helps to understand the variability pattern through the quantitative observation. Okay, next. See, so we are going to, this is see, when you see the chart formation, you can understand easily, no? In that way, full statistics is also play. Okay, so statistics is classified into two types. One is discrete statistics and another one is inferential statistics. Okay, this discrete statistics is classified into three topics. One is measure of central tendency, measure of variability, and graphical representation. Okay. Under measure of central tendency, we have a three topic. One is mean, mode, and median. And measure of variability, we have range, variance, standard deviation, and interquartile range. And graphical representation, we have three types. One is histogram, box plot, pie chart. Okay. In the inferential statistics is classified into four parts. One is probability distribution. Second one is hypothesis testing. Third one is regression analysis. And fourth one is confidence intervals. So now we are going to see each and every topic in elaborately. Okay, next. Next, ma. Next, ma. Uma ma'am. Kindly share the next slide. Uma ma'am.
Yes, ma'am. Now sharing, ma'am. 1 minute, ma'am.
Madam? Shall I try to share, madam?
Yes,
Madam,
ma'am. Yes, ma'am. Yes, ma'am.
shall I try?
Yes, ma'am. Okay, ma'am.
Is it visible now, ma'am? Is it visible now, ma'am?
Yes, ma'am.
Slide move agada, ma'am. Is it moving? Ma'am, is it moving?
Not moving, ma'am. Um,
What
types
about
of,
now?
types of statistics.
Yeah.
Number 14.
Okay, ma'am. Correct, ma'am.
Okay.
Okay. So I already told types of statistics is nothing but here we have two main branches. One is discrete type and another one is inferential.
Ma'am, can you put the slide in slideshow mode, ma'am?
Yeah. If I... Okay.
Hello, ma'am.
Sir.
In slideshow mode, ma'am.
Ma'am, shall I share, ma'am? Now there is some small network issue.
In slideshow.
Okay.
Slideshow mode.
Slideshow mode.
Shall I share, ma'am?
Yeah. Emma, what about my sharing, whether it is shown or not?
Your PPT screen, window is opening, ma'am. It is not in the slideshow.
Oh, okay, ma. I stop sharing, you do it, ma.
Okay, ma'am.
Okay.
Yes, ma'am. It is shared, ma'am.
Yeah, thank you. Next, ma.
Yes, ma'am. This one, ma'am.
Yeah, thank you, ma'am.
Okay. Next slide. Yeah.
Okay, visible, ma'am.
Okay, fine. Thank you. So first we are going to see what is discrete statistics. Okay. Through graph or tables or numerical calculations, discrete statistics uses the data to provide a description of the populations. Okay, before that we are discussing about what are the types of statistics are exhibit. No, so we have to classify it into two types. If the statistics are expressed in a graphical way or table way or numerical calculations, these are all comes under the discrete type. Is it clear? Discrete method of statistics is used to describe the data collected and summarize the data and its properties using the measure of central tendency and the measure of dispersion. Next. Next slide. Okay. Is my voice is audible now? Is my voice is audible?
Yes, ma'am. Yes, ma'am. It's clear.
Okay.
Audible.
Okay. So next one is inferential statistics. So based on the data sample taken from the population, inferential statistics makes them prediction and inference. Okay, so inferential statistics is nothing but the predictions and inference. So when we come to that topic, you can easily understand what is the prediction and inference. Okay. Actually, tables and data and graphs are involving means that is called the discrete statistics. Okay, so inferential statistics means predictions. So that prediction is, we have to check that prediction is correct or not. So for checking that statement, we are applying many concepts. Okay, so these types are comes under the inferential. So what is the use of this inferential statistics means? It is used to draw conclusion from the data. It requires statistical test performed on sample and it's drawn conclusion by identifying the difference between the two groups. Okay, not only valid the statement, it is also used to conclude the or identify the correct statements between the two groups. So that is the essential part of the inferential statistics. Okay, next. Okay. So what is the definition? Describes the main features of the collection of data. Okay. So again, here I am just giving the discrete statistics. We have already seen this table now. So move on to next one. So discrete statistics. Okay. So under discrete statistics, we have seen the four heading. First, I am coming to the measure of central tendency. Okay. So under measure of central tendency, we have a three topic. One is mean, median, and mode. I hope is all the students are very much aware about these three words from 10th standard itself, isn't it? So it's all of them known how to calculate mean, how to calculate median, and how to calculate mode. Is anybody saying what is the definition of mean? What is mean? What is mean?
Average of an item.
Yeah, very good.
Average of an item.
Yeah. Next slide. So this is the basic, that is fundamental of this statistics. Next slide, ma. Okay. Mean is just a fancy term for the average. If you add up everyone's age at that is an example. If you add up everyone's age at the party and divides by the number of people you have got your mean age. That is an example of mean. Next. See, so what is the mean? Average. Mean is nothing but average. Here I am giving the formula in the right hand side and one problem in the left hand side. The formula is nothing but summation of x by n. What is summation? It is nothing but x1 plus x2 plus etc. up to xn. Okay, n divided by n says total number of data. Okay, so here find the total of all the numbers, then divided by the amount of numbers. Okay, so here the data are 2, 2, 3, 5, 8. Okay, so how many data are there? 5 data, isn't it? So first of all, you have to add all the data and divided the total amount by number of data. That gives the mean value. I hope all are aware about how to find out the mean, isn't it? Next. So median. Median is the middle number in a shorted list. If you line up everyone from the youngest to the oldest and pick the person in the middle, their age is your median. So here they are giving one small example. Okay, median is we have, if you want to find out the middle age, their age means, so they are telling the way of approaches. Okay, so in general, median is nothing but the middle number. Okay, next. Next slide, ma. Yeah, see. So again, the right side is express the formula to calculate the median. The left side have a one small example. See, first see the formula xn plus 1 by 2. So here two different formulas are given. Okay, so where we apply these two different formulas, in what type of problem we have to apply this one. Okay, that question is arise commonly. See the first example here, 1, 3, 6, 8, 9. The data are given. So how many data is here? 5 data. No. So what is the middle value? Middle value from the 5 data. So 6 is the middle value. Okay. So the median is 6. Okay. Then what about the second one? 1, 2, 3, 4, 5, 6. 6 data is given. So how we have to find out the middle values? So third and fourth place have a middle values. Okay, so you have to add third value plus fourth value and then divided by 2. Okay, so 5 plus 5 divided by 2, that is again 5. So the median is 5. So one more example is given. So here, there the number is repeated. So you are telling that median is 5. But In the third example, the datas are 1, 4, 5, 6, 8, 9. Again, it is a even numbers. So we have in the middle portion, we have two numbers exits. One is 5 and another one is 6. The formula to calculate median is nothing but 5 plus 6 divided by 2, which is nothing but 5.5. Next. So mode. Next definition is mode. What is mode? Mode is the most common age at the party. Directly they are coming into the example. If you notice a lot of people are 22, then 22 is your mode. So the repeated value is known as mode. Okay, next. Next slide, ma. Okay. So example of mode, actually mode is nothing but a higher frequency. In a single word, we have to say that mode is nothing but a higher frequency. Okay, in the left hand side, I'm giving one, for examples here, the value which is written in the most. When you take the first example, 2, 4, 4, 5, 6, that number visible now. Here 4 is repeated, isn't it? So higher frequency is here 4. 4 is repeated 2 times. Therefore, here mode is 4. In the next example, 3, 3, 3, 4, 6, 6. Okay, so here 3 is repeated. Here the higher frequency is 3. You are not comparing whether 3 is smaller than 6 or 6 is greater than. Okay, it is not at all talking about the validity of the number. Here the frequency, how many times that number is repeated, how many times that event is repeated. Okay, that represents the mode. Okay, here 3 is repeated 3 times, therefore the here mode is 3. In the next example, 1, 1, 2, 2, 2, 4, 5. In this 2 is a higher frequency, therefore the mode is 2. And 4, 5, 7, 7, 8. In this last example, here 7 is repeated 2 times. Therefore, mode is 7. Is it clear now? I hope now you are all aware about how to find mean and how to find median and how to find out mode. Is it clear? Next. So next topic is measure of variability. Okay. So here we have a 4 topic. One is range, another one is variance, and another one is standard deviation, and last one is interquartile range. Next. So what is the range? Range gives you an idea of how spread out the age are. It is the difference between the oldest and the youngest. A small range means everyone's around the same age, while a big range means wider variety. Next. So in the right hand side gives the definition of the range. So the range is nothing but highest value minus lowest value. Okay. In the left hand side we are giving some example here. 3 examples are I quoted. One is 1, 1, 3, 5, 6. Here the highest value is 6 and the lowest value is 1. So range is 6 minus 1, that is equal to 5. In the next example, 3, 6, 6, 8. Here the range is highest value is 8 and lowest value is 3. Therefore, the range is 5. Then the third example, 2, 3, 4, 4. Therefore, the highest value is 4 and the lowest value is 2. Therefore, the range is 2. Next. So range is the simplest measure of variability. It is defined as the difference in value between the highest and the lowest observation in the data set, which I have already told, isn't it? In the previous slide itself, we have seen. For example, consider the following women weight in the data set. So here I am giving one more example. Okay, so 110, 110, 140, 150, 160 is the weight of some women. So what is the range means? Here the highest value is 160 and lowest value is 110. So the difference is 50. Here I am 160 minus 110. That is correct. Okay, the answer is 50. Next. So what is the range? So range, let Minimum is equal to the smallest observation. Maximum is equal to the largest observation. Okay. So the range is maximum minus minimum, which we have already seen. Okay. Next. So next topic is variance. Variance is a bit more complex. It measures how much the age differ from the average age. A higher variance means age are more spread out. So for finding the variance, that mean is also involving averages, ages also, averages also involving to find the variance. Okay, next. So what is variance? The formula is, actually the notation is sigma square. Sigma square. That notation is called as variance. The formula to calculate the variance is summation of x minus mu the whole square divided by capital N. What is mu? Mu is nothing but mean. Mu is nothing but mean. I'm already told now for finding the variance, the mean is involving. Okay. So summation of x minus mu the whole square divided by N. N is equal to total number of data from the given one. Okay. Here one example is given in the right hand side. See, find the population variation for 28, 29, 30, 31, 32. Some data are given. They asked to calculate the variance. Okay. So what is the first step? What are the terms involving in this formula? The formula we have x minus mu the whole square. Summation of x minus mu the whole square by n. So first step you have to find out what is mu, that is mean. So you know all of them are aware about how to find mean if one data's are given, isn't it? So here 28 plus 29 plus 30 plus 31 plus 32 divides 5 gives the answer of the mean, isn't it? A sum of all the values divided by n, that gives the mean. So 30 is the mean for this particular problem. Then second step, you have to subtract x minus mu the whole square. Okay. So x minus mu the whole square. What is x? X is given data. So first x is 28. So 28 minus 30 is minus 2. Then second data is 29. 29 minus 30 is minus 1. 30 minus 30 is 0. 31 minus 30 is 1. 32 minus 30 is 2. So you are subtracting. Then what is the next step? Then you have to square that value. So minus 2 square panna, the answer is 4. Minus 1 square value is 1. 0 square value is 0. Again 1 square value is 1 and 2 square value is 4. Then sum. Sum means we have to add all the values. That gives 10. Then you have to divide that values by n. So here how many data are available? 5 data, 1, 2, 3, 4, 5. Therefore, we have to divide the answer by 5. That gives 2. So 2 is the variance of the particular problem. 2 is the answer for this problem. Okay. So this is the procedure to find out the variance. Is it clear? Next. So standard deviation. When you take the square root of the variance, that gives the standard deviation. Standard deviation notation is nothing but sigma. Okay. In the previous slide, we have seen the formula for sigma square. Sigma square is called as variance and sigma is called the standard deviation. That is, we have to take the square root of the variance gives the standard deviation. Okay. Standard deviation is the square root of variance. It's like a variance but back on a scale that makes sense. It tells you an average how far each person ages from the mean age. That is an example. That is a definition of the standard deviation. Next. Next month. Okay. Standard deviation can be classified into two parts. One is low standard deviation and another one is high standard deviation. So what is the meaning of low standard deviation? The data points are close to the mean, meaning the values are relatively consistent. That is called the low standard. Okay. Then what is high standard deviation? The data points are spread out over a wider range, meaning there is more variability in the data. The data are very close to mean means that is called the low standard. The data are spread out from the mean means that is called the higher standard deviation. Okay. Next. So standard deviation, we have two types of formulas. So how we can separate means in the right hand side formula is a standard deviation formula for sample, and in the left hand side formula is a standard deviation formula for the population. Okay, so you know what is the difference between the population and sample. So population is a very big data. From this population, you have to pick out some sample, means that is called the, you have to pick out some data, means that is called the sample. Okay, if the samples are given, they ask to standard deviation, means you have to use the right hand side formula. If the populations are given, means you have to take the left hand side formula. Okay, so what is the difference means it is only, see here sigma is equal to square root of summation of xi minus mu the whole square by n. Okay, so here n is the total number of values and mu represents the mean. Mu is the population average, xi is the individual population value, n is the total number of population. In the sample also we say that x is a sample average, xi, this is a sample average, then xi is the individual population value, then n minus 1 is the total number of sample. Okay, next. So this is called the population. This is called the sample. When we see the diagram, when we see this one, you can easily understand the difference between population and a sample, isn't it? Next. Example of standard deviation. So here I am giving one in the here left hand side the formula is given sigma is equal to square root of xi minus mu the whole square divided by n. The formula is already we have seen in the previous slide itself, isn't it? So here sigma is the population standard deviation, xi is the ith observation, mu is the population mean, n is the number of observation. Okay, so in the right hand side I am solving one problem. One table is given, that is xi is equal to 5, 12, 15, and the corresponding frequency is given, that is 2, 4, 3. Okay, they asked to calculate the standard deviation. Okay, so what is the formula? Here we have another formula. See, first of all, you have to take xi in the vertical notation, write the xi value and also write the frequency value. Okay, the next step you have to find out the xi into fi. So 5 into 2, 10, 12 into 3, 36, and 15 into 3, 45. The next you have to find out xi minus mu. So yet we are not find out mu value, no? So how to calculate the mu value? So for finding mu value, we have one more formula. That formula is here. Watch out. Mean mu is equal to summation of fi xi divided by summation of fi. So the third column gives the product of fi and xi, isn't it? A frequency and the data's multiplication gives the third columns. That is 10, 36 and 45. Okay, you have to add all the three values. Here the addition is 91 divided by summation of fi. So total of the fi is nothing but 3 plus 3, 6 plus 2, 8. So you have to divide 91 by 8. That gives the 11.375. That is called the mean. That is called the mu value. Okay, so you have to take this mu value, then subtract that 11.375 from 5. So 5 minus 11.375 gives the negative value, minus 6.375. Okay, then 12 minus 11.375 gives the positive value 0.625. Then 15 minus 11.375 gives the positive value, that is 3.625. Okay, in the next step we have to square the answer, whether it may be minus or plus. When you square that, that will become a plus, isn't it? So when you square this particular value, you are getting the answer is nothing but 40.64. When you squaring this value, your answer is nothing but 0.39. When you square this value, again you are getting 13.14. Okay, then finally you have to multiply this answer with the frequency. Here the frequency is 2 into 40.64 gives 81.28. 3 into 0.39 gives 1.17. 3 into 13.14 gives 39.42. Then finally you have to add the last column, that gives the 121.87 divided by datas. Okay, divided by 8. Okay, so that is total output. Okay, 3 plus 3 plus 2. Okay. So that is 3 plus 3 plus 2 is 8. So we have to divide it by 8. Therefore, that gives the answer is this. This is a sigma square. When you take the root for this, then the answer becomes 3.90. So in that way, you have to find out the standard deviation. If one data is given means you have to use this formula and find out the standard deviation like this. Okay. Is it clear? Next. So one data is given in this question, they asked to find the range, variance and standard deviation of the data. So already you know that what is the definition of the range. Okay, so that is nothing but the maximum value minus minimum value that gives the range answer, isn't it? What is variance? Variance, we have a one formula. Then what is standard deviation? When we are taking the square root of the variance, that gives the standard deviation. Here one data is given, then how to find the variance? I already in the previous slide itself we solve the variance problem. No, one data is given means I know I told you know how to find out a mean value and how to calculate the variance. So using that value we have to find out. Okay, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data are here. What is the minimum value? That is nothing but minus 6. What is the maximum value? That is called the plus 6. Therefore, range is maximum value minus minimum value. That is 6 minus of minus 6. That gives the range. That is 12. Next. So kindly note down this problem. Find out the variance and standard deviation to me. Okay. That is a work for you. Here I am just, I am not explaining the methodology. I already told, so you have to take that one. Here I am giving just a formula. Okay, and the final answer. Okay, next. Next, ma. Next slide. So this is a standard
Yes, ma'am.
deviation
Next slide.
formula. Okay. Next one is interquartile range. So in general, we call it as a IQR, interquartile range. It displays the data's middle 50%. Between the first and third quartiles, it calculates the range. It is quite effective at the identifying consistent values while excluding outliers or extreme values. So when we see the next slide, you can easily understand the definition of interquartile range. Okay, go to the next slide. Okay, wait. So what is interquartile range? Imagine dividing your data into quarters. Okay. Label them from low to highest. So if you have some data means you have to divide it as a quarters. Okay. If you have 100 data, then you have to separate into 25, 20, each 25. Okay. So the first 25 is labeled as Q1. Second 25 is labeled as Q2. Third 25 is labeled as Q3 and the fourth 25 is labeled as Q4. Okay. So what is the meaning of lower quartile? That is Q1. It divides the smallest quarter of values in your data set from the higher value. Yeah, we are taking 1 to 25 data as Q1 now. So that is the smallest quarter value from your data. So in that way, we have to giving the name, isn't it? So that Q1 is a lowest quartile. And which one? What about the upper quartile? Q3 is the value that they separate the highest quarter of value from the rest of the data set. Interquartile range is the middle half of the data that lies between the upper and the lower quartile. So we have interquartile is nothing but the range between the Q1 and the Q3. Next. So this is the formula to calculate Q1 and this is the formula to calculate Q3 and that is the formula to calculate Q2. So Q1 is nothing but 1 by 4 into n plus 1th term and Q3 is 3 by 4 into n plus 1th term and Q2 is equal to Q3 minus Q1. Next. So I already told I'm separating that my 100 data into 4 parts. Okay. The first one is 25. Okay. That will be Q1. Second 25 in the middle you have to mark YouTube. And this is third 25 here. You have started with Q3 and the fourth one is Q4. Okay. So the middle between Q1 and Q3 is called the interquartile range. Next. So what is Q1? This value separate the lowest 25% of the data, which I have already told, isn't it? What is Q2? This is the middle value of the data set, which is split into 2 equal parts. Okay. What is Q3? This value separate the top 25% of the data. It is the median of the upper half of the data set. When you see the previous slide, you can easily understand the definition of the first quartile, second quartile, and third quartile. Second quartile is also known as median of the data because it is in the middle way, isn't it? Q2 is in the middle part of the data. So we have to call this that is second quartile or else median of the data. Next. So some other statistics. So interquartile range, that is formula is Q3 minus Q1. So semi-interquartile range is Q3 minus Q1 by 2. Mid-quartile range is Q3 plus Q1 by 2. This interquartile range is also classified into two simple modification. One is semi-interquartile range and another one is mid-quartile quartile range. Okay, the formula is slightly different. If it is semi, means the formula is nothing but average of, not average, that is Q3 minus Q1 by 2, and mid quartile is nothing but the average of Q1 and Q3. Next. So here I am giving one example. You are given a data set of the ages of students in a classroom. Okay. So the data are nothing but 18. 18 is age of one students. 18, 19, 20, 21, 22, 35, 13, 23. These are all the age of the students in one room. Okay. Find the interquartile range. That is the question. Okay. So how we solve this type of questions? First step, you have to arranging the given data into ascending order. Okay. So here the minimum value is 13. Next one is 18. The next one is 19. So first we have to arrange in the ascending order. So the answer is 13, 18, 19, 20, 21, 22, 23 and 35. Okay. So count how many data are involving here? 8 data now. From 13 to 35 we have a 1, 2, 3, 4, 5, 6, 7, 8 data. Okay. So median is average. If it is 8 means what is a median? If it is odd number means you can easily pick out the median, isn't it? But it is a even number, no? It is a even number, no? So here we have a median value is 20 and 21, isn't it? So lowest 13, 18, 19 is one set. 22, 23, 35 is one set. So middle we have a two values, that is 20 plus 21. You already know how to calculate the median for this type of even numbers, isn't it? So you have to calculate 20 plus 21 by 2, that gives 20.5. Okay, so keep that one as it is. Then lower half is 13, 18, 19 and 20. So median of the lower half is, again, this is the even number. So the median of the lower half is 18 plus 19 by 2, that gives 18.5. Then upper half is the remaining last 4 numbers, 21, 22, 23, 35. From this median of the upper half, let it be Q3, that is 22 plus 23 by 2, that is nothing but 22.5. Okay. So from this 4 numbers, you have to add 18 plus 19 by 2, that gives the Q1. Okay, median of the lower half. Then the 4 data in the upper half, here the median is 22 plus 23 by 2. Let it be Q3. Okay, the value is 22.5. Finally, interquartile range is nothing but the formula is Q3 minus Q1. Therefore, 22.5 minus 18.5 gives the required result. So in that way, you have to find out the interquartile range if the data are given. Okay, is it clear? Next one. So here I am giving one more example for explain my concept. This time we will use a data set with 11 values. Okay. So see, in the previous I am giving the even values, here I am giving the odd values. So this is the data. 48, 52, 57. Already is it in the ascending order, isn't it? So no need to rearrange. If it is ascending order means you just leave it and count that it is 11 data. So first half having 5 numbers and the second half having 5 numbers. Middles we have only one thing, that is 72, that is the median. Okay, so we have to find out what is Q1 and what is Q3. So let me tell from the first half, what is Q1? Middle value is 57, isn't it? Therefore, Q1 is obviously 57. What is Q3? The middle value of the second half is 81. Okay, that is Q3, isn't it? Therefore, interquartile range is Q3 minus Q1. Next slide. Yeah. The first half having a middle value is 57, that is Q1. Second half having middle value is 81, that is Q3. Formula is Q3 minus Q1, that is 81 minus 57, that gives the 24. That is the interquartile range. Next one. Yeah. I hope now you are very much clear about this interquartile range. Under measure of variability, we have seen 4 topics. One is range, second one is variance, third one is standard deviation, and fourth one is interquartile range. First of all, range is nothing but highest value minus lowest value, isn't it? Range. Then variance, we have a formula. That is a summation of xi minus mu I the whole square divided by n. That is the variance formula. When you take the square root
Madam?
of this variance.
Hello?
Yes.
Madam?
Yes, sir.
Can I ask a question?
Yeah, sure, sir.
Madam, now you showed an example, no? Like mean, median, quartiles and all.
Yes, sir.
That means you are arranging them in the order, no? But before making it in a quartile range. It's not mixed values. All the values are arranged in ascending order. Then you are trying to find that, no?
Yeah, sir. In the
So any quartile, I mean, if you have a data set or a data points required for any applications, so first all the values should be arranged in the higher order, and then we should make a quartile range, right?
Yes, sir.
And
We
first
have to
25
make, yes,
not work.
yes, sir. Yes, sir. We have to make, first step, you have to arrange in the ascending order. Okay. In the first example, I am giving in the mixed value, then I arranged it. Okay. But in the second ascending order, like okay.
So if there are repeated values also, ma'am?
Which one, sir?
Like if there are some repeated, like if we are taking this mathematics for some applications like image processing or something, if the pixel values are repeated in that case also we should take, like, how do you take the quartiles then, ma'am? Because same values may be repeated 4 or 5 times then.
Yes, sir. We have to take like this. No need to worry about that, whether that number is repeated or not. Okay. You're just arranging like this and you have to pick out the value from like this. Okay. Then you give that, then you get the answer. Okay. Even though the values are repeated, you have to apply the same concepts are for finding interquartile range. Is it clear, sir?
Okay. So repetition is not a problem. That's what you're telling.
Yeah.
So we can take
no
the
need to worry
application as
about
it
the
is.
repetition. Yeah.
Okay, fine.
Next. Yeah. Next one is graphical representation. In the graphical representation, we have a 5 charts. One is histogram, then box plot, pie chart, circle, frequency polygon, and bar chart. Next. Yeah, what is histogram? Histogram is a type of graphical representation used in statistics to show the distribution of numerical data. It looks somewhat like a bar chart, but unlike bar graph, which are used for categorical data, histograms are designed for continuous data, okay, grouping it into logical range, which are also known as pins. Move to the next slide. I will explain what is. Okay, types of histogram. Before going to this type, where we apply this histogram graph? Can you give an example? See, as nowadays, many of the colleges asked to display our result analysis, no? Okay, result analysis data, isn't it? So that data, that histogram graph is very useful to explain our result analysis. Okay. So the types of histogram is uniform histogram, bimodal histogram, symmetric histogram, right skewed histogram, left skewed histogram, and frequency histogram. Next. So in the right hand side, the graph shows the uniform histogram. The left hand side, I'm giving the definition of the uniform histogram. Okay. A uniform histogram shows uniform distribution. What is the meaning of uniform distribution? Data is uniformly distributed among the classes. Okay. So graph shows, from this graph itself, we can easily understand it. All the data are uniformly distributed. Next. Next, ma. Okay, bimodal histogram. So what is bimodal? If it has a two distinct peaks, okay, this implies that data consists of observation from two distinct groups. So this bimodal histogram is used to varying the two different data. Okay, next. From the graph itself, we can easily understand. Then symmetric histograph is also known as bell-shaped histogram. It has a perfect symmetric when divided vertically down the center. Okay, with both sides matching each other in size and shape. So this is the example of symmetric histogram. Next. Right skewed means in the right sides, right skewed histogram shows bars leaning towards the right side. This signifies that the majority of the data's points are on the left side with a few outliers reaching to the right. Next one. Next one. Next slide. So this is the left skewed histogram. A left skewed histogram occurs when the majority of students received excellent grades, but a few do badly. That is an example. Okay, resulting is an average that is dragged to the left. Okay, so left data are in the left side. So that is left skewed histogram. Next. So what is frequency histogram? A frequency histogram visually displays frequency distribution. Okay, of how often specific values appears in data. It is talk about the frequency. Each bar represents a range of values with its highest indicating the frequency of occurrence. Next. So what is box plot? Box plots are a useful way to visualize differences among different samples or groups. They manage to provide a lot of statistical information, including medians, range, and outliers. Next one. So this is the one diagram explain the box plot. Okay. So that is lower quartile, that is upper quartile, the boxes between this one. Okay. So this is lower quartile takes the minimum value, upper quartile takes the maximum value. The middle box is median. Next. So bar chart. A bar chart is also a graph and is a type of pictorial representation of data. That means what? It divides the circle into various sector. We have to divide the circle into various sector. So can you give an example for pie chart? Can you give an example for pie chart? Okay, next one. Next one. So this is the diagram. This is the diagram of pie chart. Okay. So you have to easily understand how that chart is shown here. Okay. So category A, category B, if you want to divide 4 category into that in one chart, you have to classify like this. Next one. Next one, ma. Okay. Types of pie chart. See, the pie chart having a 5 more classification. One is 3D pie chart, then definite chart, exploded pie chart, nested pie chart, and a ring chart. Next one. So this is the example of 3D pie chart. The pie 3D chart consists of the circle divided into sectors. Pie chart is nothing but the division of the circle. Okay. Each of which represents a percentage of the total values in a data set. The pie 3D chart gives the simple pie chart depth, which adds a layer of aesthetics. Okay. So, இதுக்குள்ள சின்ன சின்னதா லேயர்ஸ் உள்ளதையும் நம்ம 3Dல வச்சுக்கலாம். அதுக்குள்ள இருக்க சப்டிவிஷன் டேட்டாஸ் எல்லாம் அதுல வச்சுக்கலாம். That is a meaning. Okay. Next. In the pie chart, we cannot include the subdivisions. In the 3D pie chart, we can easily include the subdivisions data. Okay, that is a difference. Definite chart. A donut chart is a variation of the pie chart that features a hollow center displaying a data as proportional segment of a ring. This visualization type effectively shows part to whole relationship while offering additional design flexibility through the central space. Next. Exploded pie chart. By exploiting a pie chart, we mean spreading the slice of the chart slightly from each other. This design choice can several purpose. It can highlight specific section of the chart, improving readability and create a more dynamic and aesthetically pleasing presentation. Next. So nested pie chart. The nested pie chart is a specific type of chart that allows you to show symmetrical and asymmetrical tree structures in a consolidated pie-like structures. Next. A ring chart. A ring chart is a statistical graph derived from a pie chart. It consists of 2 or more pie charts of different size, stacked on top of each other. There is a circular blank in the middle part, and each arc is used to represent the preposition value of each data. Next. So the last we have seen the graphical representation. In the graphical representation, we have seen many charts, isn't it? So how the charts are played and the next one is inferential statistics. In the inferential statistics, we have 4 subdivision. One is probability distribution. Second one is hypothesis testing. Third one is regression analysis. And the fourth one is confidence interval. Whether my voice is audible? Whether my voice is audible?
Yes, ma'am, it is very clear.
Yeah, someone is in the message they are telling my audio is not audible.
But it is clear only, ma'am.
Okay. So under inferential statistics, first heading is probability distribution. Next slide, ma. So what is probability distribution? A probability distribution is a mathematical function or rule that describes how the probabilities of different outcomes are assigned to the possible values of a random variable. It provides a way of modeling the likelihood of each outcomes in a random experiment. Next. Probability data distribution in data science. So how that probability distribution is involving in data science. So understanding how data behave is one of the first steps in data science. We need to understand how the value in our data sets are spread out, and that's where probability distributions come in. Next. Why are probability distributions important? So why we say that topic is very important? Because explain how data behaves from the basis of machine learning models used in statistical tests, help identify outliers and make predictions. So these are all the points says how that probability distribution is important to data science. Next. So probability distribution, before this we need to understand the few words. One is random variable, which assign numbers to outcomes of a random events. So what is random events? Example, rolling a die. Okay. When you're rolling the die, what is a random event? The total number of output is 6, no? So random variables are, so that is a random experiment. That is called the random experiment. Okay. Then random variables are classified into two parts. One is discrete type and another one is continuous type. So discrete type means it only specify values or comes under the discrete type. Example, number of people. Number of people means counting arrays, no? So when we specified one particular data, then it comes under the discrete type. Okay. Continuous, any value in a range. In a range means, so if it is between one, what's it? Suppose the interval is 0 to 1 means how many values between 0 to 1 in the interval 0 to 1? How many values between in the interval 0 to 1? There are infinite values. There are infinite values in the interval 0 to 1. Okay. So if you are talking about that intervals, that range, then it is comes under the continuous type. If you talk about the specific value, then it is comes under the discrete type. Is it clear? Next. The probability of each outcome is greater than or equal to 0. The sum of probability of all possible outcomes equals 1. Yeah, this is the basic property of probability, which you have already studied at 10th standard itself, isn't it? Next. So types of probability distribution, I already told, one is discrete and another one is continuous. Discrete means specific topic and continuous means range. So what are the key components we applied in probability distribution? The one is probability mass function, second one is probability density function, and third one is cumulative distribution function. In the discrete type, we called that is probability mass function. In the continuous type, we called that is the probability density functions. Then cumulative distribution function is applied in both a discrete type and a continuous type. We have a separate formula for finding probability mass function for discrete type and probability density function for continuous type. Okay, next. So discrete probability, what probability distributions are called as discrete type, that is specific type. The one is binomial distribution, which you have already studied at 11th and 12th standard itself, binomial. So negative binomial is, I think that is new to you. Then multinomial, that is also new. Geometric, I don't know whether you have already aware about geometric distribution. Hypergeometric is that is advanced. Then Bernoullis and Poisson distribution. Binomial and Poisson you have already studied, no, in the probability distribution. These are all the discrete probability distribution. Next. So continuous probability distribution, we have many distributions. Few distributions are uniform, normal, exponential, gamma, beta, and long normal. Okay, usually we are applying uniform and normal. In normal distribution, in +2 itself, we have studied about normal distributions, and exponential distribution also, you are very much aware about that. Okay, but beta and long normal are very few cases only we have to apply. Okay, next. So here I'm giving a few example, not to all. So these are all the example or graphical shown the continuous distribution, that is a uniform continuous distribution, that is exponential and normal, and the discrete type I am giving binomial, geometric and hypergeometric only. Next. So we are going to see discrete type. So what is binomial distribution? Binomial distribution was discovered by James Bernoulli, okay, in the 16th century itself. And it was first published in 1713, 8 years after his death. Next. So this is the graph of binomial distribution. Next. Yeah, that is the formula to calculate the binomial distribution. NCX, P power X, Q power N minus X. Okay, then P plus Q is equal to 1. So probability distribution, that is probability mass function of binomial distribution is NCX, P power X, Q power N minus X. Okay, so that is a formula. Next. So binomial distribution can be used under the following condition. So these are all the condition needed to apply the binomial distribution. The first condition is the number of trials n finite. So n finite means it comes under the discrete type. No, what is the definition of the discrete type? It is a specific data. Okay, it must be finite. Finite. Okay, so the number of trials trial must be finite. Okay. Second one, the trials are independent of each other. The trials are independent. It is not depending. Okay, it is independent of each other. Third one, the probability of success is constant. Okay. Then fourth one, in every trial, there are only two possible outcomes, either success or failure. So this is the two possible outcomes. Next. So binomial distribution, we have a mean formula is NP, variance formula is NPQ. Next. P is probability of success and Q is probability of failure. Okay, N is a number. So these are the application of the binomial distribution. One is quality control, second one is medicine, genetics, market research and sports. How it applied in quality control means determining the probability of defective items in a batch. So where we apply this quality control, quality checking, in the food factory we apply the quality checking. Not only food factory, textile factory. If we produce one thing, we must check whether that product is quality or not, isn't it? So this probability is binomial probability is used to determining the defective items. Okay, so that play a vital role in the quality control. Medicine, assigning the effectiveness of a drug or treatment. What is the effective? Okay, so it assigning the effectiveness of a treatment. Then genetics, calculating the probability of inheriting specific practice. Then marketing research, predicting consumer preferences or behaviors. See, we are coming to the inferential statistics. Inferential statistics definition is nothing but predicting. Okay. So market research also, the concept is applied here. Binomial distribution play a vital role. And sports, we have to analyzing the probability of winning or losing a game. So sports is nothing but winning or losing. It talk about the winning or losing now. So probability distribution, especially binomial distribution, play a vital role in sports. Okay, sports activities. Next. These are all the real-time application of the binomial distribution. In all the students have one question in mind, isn't it? Where we apply this concept, why we apply this concept. Okay, so here I am telling the real-time example of the mathematics. Okay, so next, negative binomial, it is a rare case. A series of Bernoulli trials with the constant success probability that continues until a specified number of successes reached. The negative binomial distribution deals with the number of trials needed to achieve a specific number of success. Okay, it deals only the number of trials needed to achieve a specific number of success. It deals only about the success. It deals with the success only, negative binomial distribution. Okay, in simple terms, it tells us how many attempts are required to achieve a set of number of success. So they are talking about only about success. So how many times, how many attempts we need to success. So that concept is that concept comes for negative binomial distributions. Okay, it talks about only the success, not about failure. Okay, but in a binomial distribution talk about both the cases, either success or failures, but negative binomial distributions is only focusing on the success. Next. It is similar to a binomial distribution, but with one key difference is a binomial distribution, the number of trial is fixed, while in the negative binomial distribution, the number of success is fixed. I told no. So that is the difference between the binomial distribution and a negative binomial distribution. So binomial distribution means a trial is fixed. The trial yields either success or failure. But in the negative binomial distribution, the number of success is fixed. Okay, next. So this is the formula to calculate the negative binomial distribution, that is n plus r minus 1 c r minus 1 p power r q power r q power n. Okay, q power n. P plus q is equal to 1. P is a number of success and q is a number of failure. Next. So what is negative binomial? So in the last slide, we have seen about the mean and variance of the binomial distribution. Mean is NP and variance is NPQ. Similarly, the mean of the negative binomial distribution is RQ by P. The variance of the negative binomial distribution, that is formula, okay, RQ by P square. Here the mean is always greater than the variance. Okay, next. Multinomial. Used to find, it is also a rare case, used to find probabilities in experimental where there are more than 2 outcomes. So from the heading itself, we can easily understand multinomial means more than two outcomes. Okay, so this is the formula to calculate the multinomial. N factorial, product of 5 arrays from 1 to k, pi power ri divides product of 5 arrays from 1 to k ri, where r is equal to 0, 1, 2, etc. n. Next. Difference between multinomial and binomial. So I am giving the difference of both distribution. Binomial experiment can have 2 outcomes, while a multinomial experimental can have multiple outcomes. Okay. Binomial distribution have only two chances. Trial, no, that is either success or failure. Okay. So it can have 2 outcomes, while a multinomial experiment can have multiple outcomes. Next. So application of negative binomial distribution. So it is talking about only the success matter, no. So we are applying this concept in project management, quality control, customer service and call centers, marketing campaigns, insurance and risk management, inventory management. These are all the real-time application of negative binomial distribution. Next. So geometric distribution. Geometric distribution is another discrete type of distribution. It represents the number of failures before you get a success in a series of Bernoulli's trial. Okay. Our geometric distribution can be defined in 2 different ways. One is number of trials required to achieve success. Okay. Number of trials. How many trials we need to achieve our target, achieve our goal. Okay, that is one thing. Another one is by number of failures before the success. How many times we failed? How many times we failed? Okay, before the success. So in 2 ways we have to talk about the geometric distribution. Either number of trials required to success or number of failures before the success. Next. Formula for geometric distribution, yeah, that is 1 minus P. Otherwise, you may call the Q, because the relationship between P and the Q is P plus Q is equal to 1. I already told you, no. So 1 minus P, or you may put Q. So power K minus 1 into P. That is QP. QP is the probability distribution of geometric distribution. Okay, this is the probability mass function of geometric distribution. Q power K minus 1 into P. That is called the probability mass function of geometric distribution. Okay, next. Mean, yeah. Here the mean formula is 1 by P and variance formula is 1 by p minus p square. I already told instead of this 1 minus p, we have to write q because the relationship between p and q is p plus q is equal to 1. P is the probability of success and q is the probability of failure. Next. So this graphical way to explain the geometrical distribution. Next. So application of geometric distribution, where we apply, it is important to monitor and identify defective products. In business and finance, geometric distribution can be used in a cost benefit analysis, which is intended to aid managers' decision making. Next. Hypergeometric. This is also rare case. The hypergeometric distribution is very similar to the binomial distribution. Hypergeometric distribution plays a vital role in statistics and probability theory as it helps make selection from two groups without replacing the members of those groups. Next. So this is the formula to calculate the hypergeometric formula, that is KCK n minus k, Cn minus k divides NCn. Here n represents the number of items in the population and small n represents the number of items in the sample. Capital K represents the number of success in the population and small k represents the number of success in the sample. It is talk about the population as well as sample. Okay, next. Hypergeometric application is number of voters, box full of colorful balls, forming a committee at an educational organization, number of defective products in a consignment. These are all the real-time example of hypergeometric application. Next. So what is Bernoulli's distribution? Bernoulli's distribution is a discrete probability distribution. Okay. So a random experiment has only two outcomes, either success or failure, which you have already known, isn't it? Here mean is P and variance is PQ. So what is the mean and variance of binomial distribution? Mean is equal to NP and variance is equal to NPQ. Okay, in the Bernoulli's, we just give mean is equal to P and variance is equal to PQ. Next. Important notes on Bernoulli's. Okay, Bernoulli's distribution is a discrete probability distribution where the Bernoulli's random variable can have only 0 or 1 as the outcomes. So what is the outcome of Bernoulli's distribution means? Only two outcomes, either 0 or 1. Okay, P is the probability of success and 1 minus P is the probability of failure. Okay, the mean is equal to P and variance is equal to PQ. Bernoulli's distribution is a special case of binomial distribution when only one trial is conducted. Yeah, that is the difference between the Bernoulli's distribution and the binomial distribution. When only one trial comes means we have only one outcomes, either success or failures. For that here n is not involving. The formula for finding mean value to binomial distribution is NP, isn't it? And variance is NPQ. But in the Bernoulli's distribution, mean value is only P and variance is only PQ. What about that n? Here n is 1. Okay, so only one trial is conducted means that is called the Bernoulli's distribution. More than one trials are applied means that comes under the binomial distribution. Even though more than one n involving, but that n value must be finite. That is a one more note to binomial distribution. Is it clear? Next. So this is the graph of Bernoulli's distribution. Next. Yeah, next one important distribution is called as Poisson distribution. It is also a discrete probability distribution. It gives the probability of an event happening a certain number of times within a given interval of time or space. Next. Yeah. Mean and variance. In all the distribution, we have seen the formula for mean. Poisson distribution, mean value is lambda and the variance value is also lambda. Both are equal. Mean and variance are equal in the Poisson distribution. Mean is greater than the variance, that is for geometrical distribution. Mean is lesser than the variance, that is for binomial distribution. These are all the characteristic or property of the distributions. Next. So this is the graph of Poisson distribution. Next. So Poisson distribution formula is e power minus lambda power k by k factorial. In school itself, we have seen this formula. Instead of that k, we are applying the notation x. E power minus lambda power x by x factorial, isn't it? In that way, we have studied about Poisson distribution. And the notation may be anything, but concept is same. X is a random variable following a Poisson distribution. K is the number of times an event occurs. E is Euler's constant. Then lambda is the average number of times an event occurs, and the factorial is the it is a factorial function. This one is a factorial function. Next one. So what are the application of Poisson distribution? Telecommunication, it play a vital role. Finance, biostatistics, environmental studies, sports analyzing. So they are in a single word, they are explaining how that Poisson distribution applying in sports analysis is. Evaluators place performance materials and scoring occurrence during games. Okay. Financial, it helps assess risk related to default on loans or insurance claims like that. Okay. That's enough. Go to the next slide. So next we are going to see continuous type. Next. Yeah, that is an important distribution in the continuous type. The formula for continuous type is nothing but that is in the discrete type we called that is probability mass function. In the continuous type we called it is the distribution is called as density function, probability density function. Okay. So suppose the interval is A that value, B that value is lies between X and Y. Okay. Y, then the uniform distribution is f of b is equal to 1 divided by y minus x. Okay, where x is the minimum value, y is the maximum value. So maximum value minus e minimum value. Okay, that gives the probability distribution function for uniform. Next. So this is the graph of uniform distribution. So b minus a, that is b minus a, second term minus first term. Next. Otherwise, maximum value minus minimum value, in that way we have to take. Mean and variance. Yeah, this is the formula to calculate the mean of the uniform distribution. That is x plus y by 2. That is, suppose your value A is lies between x and y, means you have to add the maximum value as well as minimum value and then take average. Okay, that gives the mean. Then standard deviation formula is sigma is equal to square root of maximum value minus minimum value whole square divided by 12. Variance means sigma square. You just cut out this square root. The formula is y minus x the whole square divided by 12. Next. Discrete uniform distribution. Finite or countable number of possible outcomes. Continuous uniform distribution. An infinite number of possible outcomes within a continuous interval. This uniform distribution, I already told, uniform distribution comes under continuous type, but in a discrete type also we have a uniform distribution. But what is the main thing means the output becomes countable. If it is finite means, if it is countable means it comes under the discrete type. Okay, it is uncountable means it comes under the continuous type. Next. Application, lucky draw context, throwing a dot, tossing a coin. These are all the application of the last one. Next. Yeah, normal distribution. In general, this normal distribution is also called as Gaussian distribution, which you have already studied about 10th or 11th standard, isn't it? It is a bell-shaped probability distribution. It is a one important distribution in the continuous type. Next. Yeah, that is a formula, probability density function. the distribution function is called a probability density function because it comes under the continuous type now. So f of x is equal to 1 by sigma into root 2 pi e power minus x minus mu the whole square divided by 2 sigma square. Okay, here mu represents the mean value, sigma represents the standard deviation, and x is a variable, and e is the Euler's number. This distribution you have already known, no? Isn't it? Plus 2 itself we have studied these this distribution, normal distribution. Next. So what are the application of normal distribution in computer science means? Here I am giving few applications. One is future scaling in machine learning. Data is transferred to have mu is equal to 0 and sigma is equal to 1. Improve the performance of algorithms. Okay. The next one is Bayesian inference and probability models. And these are all the few applications of the normal distribution in computer. Okay. Go to the next slide, NF. Next. So what is the use of the normal distributions? So where we apply this normal distribution? Statistical inference and hypothesis testing. So normal distribution plays a vital role in hypothesis testing. Okay. Quality control and manufacturing, natural and social science, finance and economics, standardized testing. So these are all the places normal distribution occurs. Okay, next. So exponential distribution, this is also very important distribution under the continuous type. It is widely used to model the time or space between events in a Poisson process. Okay, next. Yeah, this is the probability density function of the distribution. F of x equal to lambda into exponential distribution. F of x equal to lambda into e power minus lambda x. Lambda is a parameter and x is the time or distance until the next event. Next. So this is the mean of the exponential distribution. Mean formula is 1 by lambda and variance formula is 1 by lambda square. Next. So this is the graph of the exponential distribution. Next. So these are all some real world applications for exponential distribution. Call centers. So how that distribution plays means time between incoming calls. So we have to calculate the time between two incoming calls. Okay. Then at the time we apply the exponential distribution. Okay. Bank queues, time between the customer arrival. Web server time between the request. Manufacturing, time until a machine part fails. Transport, time between buses or trains. So in between two times, okay, that concept is applied. That is exponential concept is applied. So between two interval comes means it comes under the continuous type. Okay, next. Yeah, gamma distribution. This is also the one of the important distribution in the continuous type. Okay, that helps us measure and predict random things. Especially we say that when the scientists are work with the data, they that only has a positive value like time or amounts. This tool helps them make sense of what they see. Okay, here is the cool part. The gamma distribution can adapt to different shapes, making it flexible. Okay, for that reason only scientists are using this gamma distributions in their project. Next. Yeah, this is the formula. This is the probability density function of gamma distribution. F of x is equal to e power minus lambda x, x power alpha minus 1, lambda power alpha divided by gamma of alpha. The formula to gamma alpha is equal to integral 0 to infinity e power minus t, t power alpha minus lambda into dt. Okay, this the notation is this gamma, this is called the gamma function. This gamma function having some property minus gamma of 1 is equal to 1 minus gamma of alpha plus 1 is equal to alpha into gamma alpha. Gamma of 1 is equal to 1. Gamma of alpha plus 1 is equal to gamma into gamma of alpha. Next. So this is the graph. explain the gamma distribution. The mean of the gamma distribution is alpha beta and variance is alpha beta square. Next. So when to use gamma distribution? So this is the graph of gamma distribution. Next. That's enough. Go to the next slide. So application of gamma distribution, again, where we apply this gamma distribution means in finance section, engineering, healthcare, telecommunication, Bayesian statistics. So these are all the few applications of gamma distributions, and I am also explaining how that distribution applied. For example, I am taking telecommunication means modeling the duration of phone calls, data transmission rates, and network traffic. So in that situation, that gamma distribution play a vital role. Okay, next. Why do data scientists use the gamma distributions? So because we are going to correlate all the statistics into data science, no? So how this gamma distribution applied in data scientist help with unpredictable events. So if you want to do unpredictable event calculation, at that time that gamma distribution play a vital role. Okay, great for rare events. If something only happens occasionally, like a rare, this distribution can still make a good prediction. So rare events are happening means at that time we have to apply the gamma distributions. Okay, works with the positive only data. Since we are talking about things like time or amounts, the gamma distribution make sure we only get positive numbers. Okay, next. So unpredictable events la we have to apply the gamma distribution. Okay, and also rare events la we have to apply the gamma distribution. Next. Real life example of gamma distribution, one is waiting times, then rainfall, lifespan of products. Okay, I'm explaining how it apply that gamma distribution. Okay, next. Yeah, the next one is beta distribution. It is a rare distribution. Mainly we used only the gamma distribution. Here I'm giving the definitions. The beta distribution is a continuous distribution. It can only take on values between 0 and 1. The primary use of the beta distribution is being the conjugate prior in Bayesian statistics to the binomials and Bernoulli distributions. Next. So this is the mathematical formula to find the beta distribution. F of x is equal to x power alpha minus 1 into 1 minus x whole power beta minus 1 by b of alpha comma beta. Next. So this is the graph of beta distribution. Next. Two parameters are involving, one is alpha and another one is beta. So beta of b of alpha comma beta is equal to gamma of alpha into gamma of beta divided by gamma of alpha plus beta. This is called the beta function. Next. So what is the mean and variance of the beta function? Mean of beta function is alpha divided by alpha plus beta, and variance of beta function is alpha beta divided by alpha plus beta into 2 times into alpha plus beta plus 1. Next. What are the applications of beta distribution in data science? Okay. It has several important applications. Okay, so particularly Bayesian statistics and machine learning. One of its primary uses is a conjugate prior of Bernoulli's binomial, negative binomial, and geometric distribution in Bayesian inference. So it gives much more importance to conjugate. Okay, this means that when updating beliefs about probabilities based on new data, the beta distribution allows for straightforward calculating without the need for complex numerical methods. Next. Log normal distribution. This is also the rare case. The reason that this distribution is called a log normal is that if x is log normally distributed random variable. Okay, for that only we are calling this as the log normal distributions. Okay, it is normally distributed. Consequently, the log normal variable itself is strictly positive and often called right skewed. Next. So this is the graph of the log normal distribution. Next. Yeah, next. So log normal distribution models data that grows multiplicatively over time, like stock prices or income. Models multiplicative growth process. Data cannot be negative, commonly used for stock prices and incomes. It only models positive values. So the main thing is, one important things for applying log normal distribution is your data must be positive. Okay, you cannot give the negative values. Okay. If it is negative, means we cannot able to apply the log normal distribution. Okay. It deals about only the positive. Next. So log normal, that is normal. Y is equal to ln of x normal. Y is equal to exponential of y. That is log normal. Next. So the definition of log normal is here. 1 by x into root of 2 pi sigma square exponential of minus half into log x minus mu the whole square divided by sigma square. So that is the distribution. Next. So what are the, here as I'm giving some example of log normal: milk production by cows, amount of rainfall, size distribution of rainfall, tablets, the volume of gas in a petroleum reserve. Next. Log normal in data science. Log normal distribution appears in many scenarios because it naturally models positive value that tend to cluster at low values with occasional high outliers. Then financial data provides classical examples. Stock prices cannot go below zero but can rise dramatically, creating the characteristic right skewed pattern. Next. Yeah. Inferential, first we have complete the distribution, probability distribution. Under the probability distribution, we have two topics. One is discrete type and another one is continuous type. In the discrete type, we have a few more distribution. Few of them are binomial, Bernoulli, Poisson, and in the continuous type, we have a few distribution. One is uniform distribution, exponential distribution, gamma distribution, and beta distribution. Okay. The next topic is hypothesis testing. So what is hypothesis? Hypothesis is nothing but the statement. Okay. So we are going to test the statement. So that is the concept of this hypothesis testing. Hypothesis testing to mutually exclusive statement about a parameter or population. Okay, next. So we are going to testing one hypothesis. That's all. That is the hypothesis testing. So parameters and statistics. So before going to this hypothesis testing, we have to know about what is parameters. Okay, in statistics, a parameter is a description of a population, while a statistics describe a small portion of a population. That means a sample represents the statistics, population represents the parameter. Is it clear? Next. Yeah. Hypothesis testing. Hypothesis testing compares two opposite ideas about a group of people or things and use data from a small part of that group to decide which idea is more likely rare. Okay. Before going to this one, I want to explain what is hypothesis testing. For example, in a real life, I'm giving one example. Okay. We are giving advertisement to one product. That product may be anything. Okay, we are giving the advertisement. Okay, there are whether that advertisement is useful for the product or not. That is the question. Okay, whether that advertisement is useful to the such product or not. So what is the purpose of advertising one product? We want to increase the output. No, we want to increase the customer, isn't it? We want to increase the customer. Okay, if we increase the customer, then only our product will be successful, isn't it? So advertisement are used to increase the customer. Okay, so your question is whether that advertisement is help to increase the product or not. Okay, so that is the question. That is the statement. So here we have a 5 subdivision to solve this type of problem. The first one is you have to take the null hypothesis. Null hypothesis means there is no difference between the data. Okay. Alternative hypothesis means that is the just opposite of null hypothesis. Okay. That is the complicate opposite of, that is complicated of null hypothesis. Okay. So for this question, whether that advertisement is useful or not, that is the question. No, in the first step, you have to take your null hypothesis is as null hypothesis generally denoted by the letter H naught. Okay. Null hypothesis as there is no difference between the data. I am giving like this. Okay. So there is no uses for giving the advertisement. Okay. That is your null hypothesis. There is no difference. So before the advertisement, after the advertisement, there is no change. Okay. That should be your null hypothesis. In all the problem, you have to keep your null hypothesis like this. Okay. Alternative hypothesis, there is a difference. There is a lot of difference. There is a difference between the data. That means before the advertisement and after the advertisement, we have a difference. Okay, you have to take that statement as alternative hypothesis. In all the problem, you have to take your null hypothesis as no difference. Okay, in the alternative hypothesis as there is a difference. Okay, next. So this is the graph explaining null hypothesis and alternative hypothesis. Null hypothesis is denoted by the letter H naught and alternative hypothesis is denoted by the letter H1. Next. Next. Yeah. Types of hypothesis. A type of hypothesis. Yeah. We have two types. One is one-tailed test and another one is two-tailed test. Because we want to test the hypothesis. No. After testing the hypothesis only, we come to the conclusion. Okay. For testing, we have two types. One is one-tailed. Hello. So we have two types of hypothesis. One is one-tailed test and another one is two-tailed test. This one-tailed test is also classified into two categories. One is left-tailed, another one is right-tailed. Then two-tailed is equal. Okay, two-tailed is equal. Here this H naught represents the null hypothesis. Here mu is mean. Okay, so mu is, we may define one-tailed test is like this. H naught colon mu not equal to 50. Okay, like this. Next. So what is one-tailed test? Used when the research hypothesis specific a direction of the effective or relationship. Okay. Example, testing if a new marketing strategy increase sales compared to the old strategy. So I am telling no. Okay. Then two-tailed test means used when the research hypothesis does not specify a direction, focusing only on whether a difference exists. Okay. Testing if a new teaching method has any impact, positive or negative, on students' performance compared to the old methods. Next. So here I am just giving the definition of the one-tailed test and two-tailed test. That's all. What is one-tailed test and what is two-tailed test? Okay. So this is the mathematical definition. One-tailed test means the rejection of region. Rejection of region is on one end of the distribution. Then section 1, two-tailed test. Next. Next one. Next slide.
The function of the organs make up the.
So when to use each test? One-tailed test, when prior research or domain knowledge suggests a specific direction, we have to use the one-tailed test. When the direction of the effective's uncertainty or both direction, we have to apply the two-tailed test. So the domain knowledge suggests a specific case means we have to apply the one-tailed test. The domain knowledge about the specific case means one-tailed test. Okay. In the uncertainty case, we have to apply the two-tailed test. Next. Yeah, before going to this testing of hypothesis, all of them must aware about this type errors. Okay, so here the errors are called two types. One is type 1 error and another one is type 2 error. So what is type 1 error? False positive, rejecting H naught when it is true. It is a error. Okay, so H naught is nothing but the hypothesis. Okay, when the statement is true, but we reject it. Okay, that is called the type 1 error. Type 1 error occurs when the null hypothesis is rejected even though it is true. Example, a medical test wrongly conclude that a patient has a disease when they do not. Okay, so the patients have actually no disease, but that statement tells that the patient have a disease. Okay, so it is wrongly said no. So this comes under type 1 error. That means H naught is true. What is H naught here? The patient have no disease. That is H naught. Okay. But it is rejecting H naught. Reject H naught means the patient has no disease or reject பண்ணுது. Okay. That means it accept it. Okay. That is called the type 1 error. Next. That is type 2 error. Accept H naught when it is false. Suppose the statement is false, but we accept that statement. That is called the type 2 error. Example, a medical test failed to detect a disease that the patient actually has. Suppose the patient have some disease, but it is accept the null hypothesis. Okay, medical test failed to detect a disease. Okay, that comes under the type 2 error. Okay, false negative. Okay, accept the H naught, accept the null hypothesis when it is false. Okay, next. Yeah, so here standard error happens, isn't it? When we calculating something means error happens. No, here type 1 error and type 2 error. Okay, so here I'm giving this definition of the standard error. Next. Yeah, these are all the steps involving to test the hypothesis. The first step is define null and alternative hypothesis. Next, choose significance level. Then collect and analysis the data. Calculate the test statistics. Then statistical decision whether we have to accept the H naught and reject the H naught. Do not reject means accept. Okay, accept the H naught or reject the H naught. Conclude. Do not reject means accept H naught. If you are accepting H naught means obviously you reject the H1, isn't it? Okay. So reject the H naught means you obviously accept the H1. That is alternative hypothesis. Therefore, we conclude H1 as true. So these are all the 5 steps involving in the testing of analysis. Next. Yeah, level of significance play a vital role. Here we have a 3 level of significance. One is 99% level of significance, then 95% of 5% level of significance, and a 10% level of significance. Suppose in the problem itself they are not mentioning the level of significance. In general, we have to take 5% level of significance. Okay, next. So types of hypothesis testing. I'm telling no, here we have a many types to testing the hypothesis. One is Z test, then next T test, third one is chi-square test, and fourth one is ANOVA test. Next. So what is Z test? For Z test, we have one formula. Go to the next slide. Yeah. So this is the formula for testing the hypothesis. For testing the hypothesis, we have 5 steps now. The first one is null hypothesis, second one is alternative hypothesis, third one is level of significance, and fourth one is test statistics. So test statistics, we have to identify the identify which test apply in this situation, and apply the formula. So this is the formula for Z test. Suppose the given problem is one sample, you have to apply Z is equal to x bar minus mu naught by sigma by root n. Suppose if the given problem having 2 samples, we have to apply this formula x1 bar minus x2 bar divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. Next. So T test, that is another test. That is usually called student T-test. It is a very famous test. The test value n is below 30, then we apply this t-test. Next. Yeah, assumption in t-test. I'm saying no, t-test is very important. So here I am giving the some assumption of t-test. It should be independence, then normality, homogeneity of variances, and absence of outliers. These are all the assumption of t-test. Next. Yeah, this is the formula. Already we seen the formula for Z test for one sample and two sample. Here I am giving the formula for T test. If it is one sample, then T value is equal to X bar minus mu by S by root n. Okay, here X bar is observed mean of sample, mu is mean, S is standard deviation, and N is a sample size. In two sample test are given means X1 bar is a observed mean of first sample, X2 bar is the observed mean of second sample. S1 square is the standard deviation of first sample. S2 is the standard deviation of the second sample. N1 is the sample size of first sample. N2 is the sample size of second sample. So this is the formula for t-test. Next. Yeah, degrees of freedom. Degrees of freedom is N1 plus N2 minus 1. And we have another formula for two sample test that is called S1 square and S2 square. Okay, that is the variance. Okay, so summation of samples are given means we use the previous slide data. Suppose variance are given means we have to apply this formula. That is summation of I bar is from 1 to N1 xi minus xi bar whole square divided by n1 minus 1. S2 square is equal to xj minus x2 bar the whole square divided by n2 minus 1. So this x1 bar and x2 bar represents the mean of the first data, mean of the second data. This n1 is the number of sample in the first data, n2 is the number of sample in the second data. Next. Paired sample t-test. So this is the summation of x1 bar minus x2 bar by s divided by root n. That is a formula for t-test. Next. So when to choose a paired t-test? Choose a paired t-test if you have two measurement on the same item, person or things. For a particular item, we have two measurements. Okay, at that time we have to apply the paired t-test. Okay. Next. Yeah, next important thing is chi-square test. Chi-square test indicates that there is a relationship between two entities. So chi-square statistics test that measure how a model compared to actual observed data. Next. Yeah, this is the formula to calculate the chi-square test. Chi-square test is equal to summation of observed frequency minus expected frequency, the whole square divided by expected frequency. Next. So when to use the chi-square test? You want to test a hypothesis about one or more categorical variable. If one or more of your variable is quantitative, you should use the different statistical test. Sample was randomly selected from the population. There are a minimum of 5 observations expected in each group or combination of groups. So at that time, we have to apply the chi-square test. Next. So two types of chi-square test here we have. One is goodness of fit and another one is test of independence. Mathematically, these are actually the same test. However, we often think of them as different tests because they are used for different purpose. But both are same. Okay, but we have to apply goodness of fit and independence of attributes in a different purpose. So we are classified into two types. Next. Yeah, what is goodness of fit? Goodness of fit, you have one categorical variable. It allows you to test whether the frequency distribution of the categorical variable is significantly different from your expectation. Next. Next one. Yeah, independence means it have two categorical variables. Okay, next. Chi-square test application. Chi-square test is used in cryptanalysis to determine the distribution of plain text and decrypted text. Similarly, it is also used in bioinformatics to determine the distribution of difference like disease and other important genes. A chi-square test is performed by various researchers of different fields to test the minor or major hypothesis. Next. Yeah, this is the important in the chi-square test that is called the consistency table for 2 by 2 data. For 2 by 2 data, okay. Suppose the data, first data is AB and second data is CD. Okay. So you have to calculate A plus B by 2 and C plus D by 2. This side we have A plus C by 2 and this side we have B plus D by 2. Totally we have A plus B plus C plus D. Okay. In that way you have to calculate it. Next. Yeah, this is the contingency table for 3 by 3. So first row here I'm giving 3 rows and 3 columns. Okay, in the first row, row 1, column 1 having data A. This is B, C, D, E, F, G, H, I. So the total value is A plus B plus C. Okay, here the total value is A plus D plus G. Okay, column wise total, this is row wise total. Okay, then capital N is equal to total of all these things, A plus B plus C plus D plus E plus F, G plus H plus I. Both the totals are equal. Both the totals are equal. Total number of samples are equal here. Okay. So in that way, you have to calculate the contingency table for 3 by 3. Next. Yeah. Next one is analysis of variance. Analysis of variance. ANOVA is a statistical test used to examine differences among the mean of 3 or more groups. Okay, so the groups are large. At the time, we have to apply the ANOVA table. So before going to the ANOVA, we need some key concept that is called sum of square. We define by the letters SS, sum of square. Then SST, that is called sum of squares of total. SSB, sum of squares between the data. Then SSW, sum of squares within the data. These are all the key concepts we need to solve the ANOVA type problems. Next. So mean square, again, this key concept also we need the average of square deviation calculated for both between group and within the group variability. Next table, I am giving the formula for all these things. Go to the next one. Yeah, types of analysis. Here we have 2 types. One is one-way classification and another one is two-way classification. Next. Yeah, steps in conducting ANOVA table. Again, the same concept. For testing hypothesis, we have 5 steps, null hypothesis, alternative hypothesis, and testing level of significance, test statistics, and conclusion. Similarly, the same concept also applying in ANOVA table. First one is null hypothesis, second one is alternative hypothesis, third we have to calculate the SST, sum of squares of total, sum of squares between the data, sum of square within the data, SSW, SSB. Okay, next we have to calculate the mean square. Okay, SSM. Okay, then divided MSB by MSW. That means mean square between value is divided by mean square within value. Then finally we have to calculate the F ratio. When we see the table, you can understand easily. Go to the next slide. Go to the next slide. Yeah, this is the table for one-way ANOVA table. Here one-way ANOVA table means only one group is involving, between groups and within groups. Okay, so between groups, degrees of freedom is K minus 1. Here we calculate the SSB, sum of squares between the group. Okay, sum of squares within the group. So what is MSB? MSB is SSB divided by degrees of freedom. Okay, then what is MSW? SSW divided by N minus K. What is F? MSB divided by MSW. MSB divided by MSW. See, in general, F ratio is always less than 1. Okay, you may change this order also. Suppose this value, MSW value is lesser than MSB, then you have to write the reciprocal also. Okay, but F value is lesser 1. Okay, less than 1. Next. Yeah, this is called a two-way. Here we have between column is source of variation, between row is another source of variation, between treatment is another source of variation, then error. Okay, so sum of square is SSC, sum of row is SSR, sum of treatment is SSK, then error is SSE. So degrees of freedom is here noted by K minus 1, and this is also K minus 1, this is also K minus 1, then residual error is K minus 1 into K minus 2. So mean square value MSC is equal to SSC divided by K minus 1. MSR is SSR divided by K minus 1. Then MSK is SSK divided by K minus 1. This MSK is called mean square treatment. MSR is called mean square rows. MSC is called mean square columns. Okay. Then this is for error MSE. Then finally variance is FC. That means between FC means column. Column ratio is equal to MSC divided by error MSE. Then row ratio is MSR divided by MSE. Then the last error treatment is MSK divided by MSE. The denominators are errors. Numerators are mean square value of column and corresponding row, and this is treatment. Okay, all the value is greater than 1. Next. Yeah, hypothesis testing in data analysis. How this hypothesis testing is involving in data and data science. Okay, hypothesis testing is a critical statistical tool used in data science to make informed data-driven decisions. In data science, this is huge. You don't want to act on every blip in your dashboard. You want to act on what's statistically meaningful. Most data science problems involve uncertainty. Okay, next. So top tool every data scientist should use for hypothesis testing. So here I am involving some data science tools which you are already very much aware about this. One is Python, next R, Excel, Power BI, then Google Globe, JASP, SPSS, Minitab, then PySpark, SQL. Next. Yeah. The last topic of inferential statistics is nothing but regression analysis. Okay, regression analysis is a statistical method that examines the mathematical relationship between one or more independent variables and one or more dependent variables. So regression analysis is it's a mathematical relationship between one or more independent variables and one or more different variables. So it talks about both relationship between one or more independent variables as well as dependent variables. Next. Yeah, it helps, that regression analysis helps predicting future values, understanding relationship between variables, identifying important factors influencing the target. Next. Here we have a few types of regression analysis are given. One is simple linear regressions, multiple linear regressions, polynomial regressions, logistic regressions, ridge regressions, lasso regression. Next. Yeah, and in the right side, I'm giving the graph of simple linear regressions. In the left side, I'm giving the definition of simple linear regressions. Studies relationship between two variables. Okay, example, predicting the sale of a product based on advertising expenditure. Okay, next. Multiple linear regressions. In the right side, I am giving the graph of multiple linear regressions. In the left side, I am giving the definition of the multiple linear regressions. Okay. Multiple regression means more than two regressions are involving. Okay. The values are dependent variable based on two or more independent variable. Okay. Next. Polynomial regression finds and represents complex patterns and nonlinear relationships. Next. Logistic regression, the graph shows the logistic regressions. Actually, what is logistic means? Estimates probability based on predicted variables used for categorical outcomes. Example, yes or no types. Next. Ridge regressions, graph shows what is ridge regressions. Next. Lasso regression used to minimize effect of correlated variable on predictions, addresses multi-collinearity and future selection. Example is optimizing machine learning models for better accuracy. Next. Why is regression important in data science? So where we apply this regression concept in data science means regression forms the backbone of many supervised learning problems. It is widely used in financial forecasting, marketing analysis, demand estimation, risk management, and health diagnostic. Next. So real world application is again finance, healthcare, and marketing. Next. So inference statistics, last topic is confidence interval. Next. So I already told you now here we have three types of interval. One is 10% interval and 5% interval and 1% interval. The 10% interval is called as 90% confidence level. 5% interval is called as 95% confidence level and 1% is called as 99% confidence level. Next. So this graph explains the level of confidence. Next. So again, one more graph I am giving for 95% of confidence interval. Next. When do you use confidence interval? Okay. So you can calculate confidence intervals for many kinds of statistics, including proportions, population means, difference between population means or proportions, estimates of variation among groups. Next. The confident interval formula is nothing but x bar plus or minus z into sigma by root n. Okay. Ci represents the confidence interval. X bar is the population mean. Z bar is the critical value of the Z distribution. And sigma is the standard deviation which you have already known. And n is the size, population size. Next. Factor that affect confidence interval. So what are the factors make impact in the confidence interval means sample size. Okay. When the size is large, then it make a great impact in the confidence level. And higher confidence level result in wider intervals because they provide more assurance that the true parameter is contained within the interval. Next. Why confidence intervals are important in data science? Yeah, because of accuracy checking. Accuracy checking is a very important things in the day-to-day life. So this shows us how precise our results are, how correct, how accurate our data are. So that time the confidence interval is applying here, then better decision by giving a range where the true values likely fall. They help us make smarter and more informed choices. Okay, then comparison. The comparison of confidence interval very much help to comparing the two data. Okay, so we apply that concept in the data science also. In short, confidence intervals help us trust our analysis and avoid overconfident conclusion. Next. So application of confidence interval in data science are it is everywhere. Confidence intervals are everywhere in the data science, especially in model evaluation, A by B testing, predictive analysis. In short, confidence interval bring clarity and confidence to data-driven decisions. Next. So technical concept need to learn before start data science. Yeah, machine learning, modeling, statistics, programming, and database. These are all the basic concept we need before going to data science. Next. So machine learning. So here I am giving the one example of machine learning life size and give the this side left side I am giving the definition of machine learning. I hope you are very much aware about this machine learning because you people are computer science people now, so you are very much aware about this one. Next month. Machine learning is the backbone of data science. Data scientists need to have a solid grasp of ML in addition to basic knowledge of statistics. Next one is modeling. Mathematical models make able you to make quick calculation and prediction based on what you already know about the data. Next. It is used to identify the algorithm, that modeling. Okay. Next. It is also a part of the machine learning. Modeling is also a part of the machine learning. Okay. So statistics, already we have seen many things about the statistics. Next. Yeah, programming. Some level of programming is required to execute a successful data science project. Okay, so this is the one example of programming execution. Next. So database, a capable data scientist need to understand how database work, how to manage them, and how to extract data from them. Next. Data science. What skills make a data scientist? So if you want to become a data scientist, you have to you have to cultivate the following knowledges. First one, the knowledge of machine learning. You have to develop the knowledge of machine learning. Second one, strong knowledge of Python, SAS, or then hands-on experience in SQL database coding, ability to work with the unstructured data from various sources like videos and social media, understand multiple analytical functions. So these are all the skills needed to learn a data science. Next. So what is data science? Data science is using data to solve problems, answer questions, and make decisions. Okay, it combines skills like math, programming, and understanding data to find patterns, make predictions, and uncover insights. Next. So here, introduction of the data science. It is an essential part of many industries today, given the massive amounts of data that are produced, and is one of the most debated topics in IT circles. Its popularity has grown over the years, and companies have started implementing data science techniques to grow their business and increase customer satisfaction. Next. So data science is the domain of study that deals with the vast volume of data using modern tools and techniques, including essential data science skills to find unseen patterns, derive meaningful information, and make business decisions. Next. Yeah, data scientist daily task. So discover pattern and trends in data set to get insight. So that is the one important thing. Create forecasting algorithms and data models. Okay. Improve the quality of data or product offering by utilizing machine learning techniques. Distribute suggestion to other team and top management. In data analysis, use data tools such as R, SAS, Python, or SQL. Top the field of data science innovations. So these are all the essential qualification needed to develop as you are a data scientist. Next. So where we apply this data science, okay. Healthcare system, we apply this data science. How it plays? Healthcare companies are using data science to build sophisticated medical instruments to detect and cure disease. Okay. Next one. Gaming. In gaming also data science played a vital role. Video and computer games are now being created with the help of data science, and that has taken the gaming experience to the next level. So this figure shows the data science in gaming. Next. Third application is image recognition. Identifying patterns is one of the most commonly known application of data science. in images and detecting objects is an image is one of the most popular data science and applications in Aadhaar card and in everywhere we apply, everywhere we need in this image recognition. Okay, so data science played a vital role. Next, it is used to applied in image recognition field. Next. Yeah, recommendation system. Next up in the data science application list comes recommendation system. Netflix and Amazon gives movie and product recommendation based on what you like to watch, purchase, or browse on their platforms. Yeah, even though many websites are giving their products. Shows their products, okay, but as a customers you have to pick out what things you need. Okay, so recommendation system, so big data recommendation system, then recommendations. From this big data what you need, from this big data what you need, so to extract from big to our needs, that data science applied a vital role. Next. Yeah, logistic is very important things nowadays. Okay, data science is used by logistics companies to optimize routes to ensure faster delivery of products and increase operational efficiency. Yeah, if you produce one things, then you must output that things, no. So logistics that 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 place logistics is apply. Okay, that data science plays a vital role in logistics, um, to ensure faster delivery, to ensure the faster delivery. Next. Yeah, fraud detection. So this is the most important things of data sciences, fraud detection. Nowadays, many fraud, online fraud are happening. Digital arrest and the digital locks are happened. Okay, so this data science, that is fraud detection, plays a vital role, and it is also essential now. Next. So internet search. How is data science used in internet search? Internet comes the next in the list of application of data science. When we think of search, we immediately think of Google, isn't it? So if you want to search means we just go to the Google and type the name. Okay, then we get. So instead of this Google, many things are comes. Whether I hope as a computer science students all are aware about that searching websites. Here I am giving some name, Yahoo, then DuckGo, AQL, Ask, and others that apply data science algorithm to offer the best results of our searched query in a matter of seconds. Next. Yeah, speech recognition is one of the most common known application of the data science. How that face recognition is going on, the same importance also go to the speech recognition. It has a wide range of application from virtual assistants and a voice controlled device to automated customer service systems and description service. Next. So voice recognition is applied like this. Here I am giving the diagram using data science. Next. Yeah, targeted advertising. Yeah, the most important things things is advertising. If you thought search was the most essential data science use, consider this the whole digital marketing spectrum. Yeah, what is the purpose of digital marketing? They want to exhibit their product in the online market using huge advertisement, isn't it? So this CTR, call thought rate, have a fair higher than a traditional marketing. Okay, next. So airline route planning. Okay, so airline route planning means It is easier to predict flight delays for the airline industry, which is helping it grow. It also helps to determine whether to land immediately at the destination or to make a stop in between such a flight from Delhi to the United States. Here I am giving the example. I am giving the graph of airline route planning. Okay, next. So augmented reality, this is also one important things of data science. Next. Application of AR in print media. So this graph shows what are the applications are covered here. Animated covers, interactive tutorials, virtual try, and gamification of content, interactive AR advertisements. Next. So what are the challenges? What are the questions are in front of data scientist? Okay. Some of the common challenges that a data scientist faces. The first one, handling large and messy data set that require cleaning and organization. Yeah, we have a large data means we don't know how to separate it. Okay, and the data are also messy means we feel somewhat difficult to finalize. So this is the very big challenge to the data scientist. Second one, selecting the right tool and techniques for analysis. So we have a lot of tools on the platform. So we have somewhat confusion to select which tool is right for analysis and test. Okay. Third one, ensuring accurate and unbiased result. Okay. So we have to get we need accurate result. Okay. Communicating complex finding to non-technical stakeholders, aligning data projects with the business goal, keep up with the rapidly evolving technologies, managing data privacy and security concerns. So these are all the challenges in front of the data scientist. Next. So discover patterns and trends in data sets to get insights, create forecasting algorithms and data models. So these are all the data scientist tasks. Here I am mentioning over a few tasks. Okay. Top the field of data science innovation. Next. What is the difference between the data science, artificial intelligence, and machine learning? Okay. So we have to, artificial intelligence makes a computer like a human. Okay. Data science is an AI subset that deals with the data methods, scientific analysis, and the statistics, all used to gain insight and meaning from data. Machine learning is a subset of AI that teaches computers to learn things from provided data. So that is the difference between the data science, AI, and machine learning. Next. What kind of problems do data scientists solve? So data scientists can solve loan risk mitigations, pandemic trajectories, effectiveness of various types of online advertisement, resources allocations. Next. Yeah, what is the connection between statistics and data science? Statistics is the backbone of data science, playing a crucial role in analyzing and interpreting data. It helps data scientists uncover patterns, make predictions, and drive data-driven decisions. Next. Yeah. What are the types of data? Here we have two types of data. So one is qualitative data, another one is quantitative data. In the qualitative data is nothing but data that cannot be expressed as a number. Okay, example, favorite color and feelings. Feelings we cannot express as a number, no feelings. Okay. Quantitative data is data that can be expressed as a number. Example, age, height. If you are express your thought as a number finite, then it will be come under the quantitative. Otherwise, it comes under the qualitative. Okay. Next. Scales of data measurements. So here we have a 4 scales. So one is nominal, ordinal, interval, ratio. So what is nominal? Nominal means categories data without a natural order. Example, gender, nationality, eye color. These are all comes under the nominal. Ordinal means categories data with the natural orders but without consistent difference between levels. Example, satisfaction rating. Unhappy, we cannot rating, no. How much unhappy, isn't it? We cannot define. Then happiness, we cannot define. Okay, interval. Definition is numerical scale with equal intervals between values but no true zero. Example, temperature. Temperature is between this and this. It cannot become to zero, no? Then ratio. Definition is numerical scale with equal intervals and a true 0 point. Example, weight, height, age. So this is the ratio. Next. So common statistical test, choosing your data's best friend. So what are the common statistical tests we are applying in data science means, here I am telling you few things. Based on their experience, you try to infer what the entry party was like. This is essentially what inferential statistics does with the data. When you are going to the inferential statistics, we can get the many statistical test options. So you have to take any test to choose your data is the best friend. Okay, next. Yeah, applications of statistics in data science. So these are all the few applications here I am mentioning. One is data collections, and then data cleaning, exploratory data analysis, future engineering. Next. Model building using statistical models like linear regressions, logistic regressions, or decision trees to make predictions or classify data. So how that statistics apply here, I'm explaining this. Model evaluations, hypothesis testing, formulating and testing hypothesis about relationship between variables to draw valid conclusion. Yeah, hypothesis testing is used to validate our statement. Then A/B testing, comparing the performance of different versions of a product or website to determine which one is more effective using statistical significance test. Next. Who oversees the data science process? Okay, so business managers, IT managers, and data science managers. The fundamental statistics concept for data science. So we have already seen about correlation. So that correlation is one fundamental statistics we applied in data science. Correlation is in general lies between -1 to 1. And previous itself, we have seen many correlation types, isn't it? Next slide. Yeah, regression. Regression also we have seen. It is also a one important statistical method used to model the relationship between the different variable and one or more independent variables. So regression lines makes the relationship between the different as well as independent variables. Okay, logistic regression is used when the different variable is categorical, such as predicting whether a customer will churn or not. Next. Next, bias. Okay. Bias refers to systematic errors in data collections, analysis, or interpretation. Next. Probability. Next. Statistical analysis is the process of testing hypotheses and making inference about data using statistical techniques. Next. Normal distribution. We have already seen many things about normal distribution. Next. Yeah. So what are the fundamental concept applying in data science means the first one is correlation. Next one is regressions. Then normal distributions. And then testing of hypothesis. So these are all the fundamentals we applied statisticals in data science. Okay. Top 10 data science tools. Already I noted some tools. Here I am giving a SAS are best suited for statistical analysis. Then advanced tools like TensorFlow and libraries like NLTK, and also it can be used in machine learning projects. Next. Yeah, statistical software used in data science. So these are all the statistical software used in data science. Already I gave all these things. Next. So Python. So here I am giving one model of application of data science in Python. And here I am giving the definition of this. One of the leading data science tool worldwide. Next. Matplotlib. Here the graph represents that one. It is widely used in create a high quality charts, plots, and data visualization. Next. TensorFlow. So this is the graph for TensorFlow. It is a machine learning library used to build and deploy ML models. Next. The Natural Language Toolkit, NLTK. It is a popular library used in Python for natural language processing. It is especially suitable for working with the human language data like translation and classification. Next. So here I am giving the graph. What are the NLTK are applying here? And a data visualization framework. D3 is a JavaScript library used to create data visualization. It is vital role is to create the data visualization on the web. Next. Statistical analysis R is also leading open source of data science tool known for its statistical computing capabilities. However, R has a comparatively steeper learning curve than Python. Next. Due to its user friendliness and flexibility, scikit-learn, an open source library of Python, has become the most used library in the entire field of data science. Next. 9 is a data analytic platform that offers a graphical interface for a data scientist. Here I am giving the graph of this. Next. It is especially in the team collaboration. 9. Okay. Next one is Vika. It is also it is for knowledge analysis. Okay, for an open source data mining software. It is written in Java and it is particularly famous for its graphical use interface. Next. Vika. Okay, yes. That is statistical analysis system. Is a programming language with a strong statistical analysis capabilities and data management features. It also has a comprehensive suite of tools for different tasks in data science. So here I am mentioning types of statistical analysis: descriptive, prescriptive, exploratory data analysis, causal analysis, predictive analysis, and inferential analysis. These are all the types of statistical analysis. Next. So application of statistics for data science. Overall, we can say that statistics for data science is help to apply statistical analysis technique to solve the real world problems, discover the valuable information that the data contains, generate the prediction based on the data, communicate your results properly, draw conclusions that facilitate design making in complex situations, recommended online courses. These are all the application of statistics for data science. Next. Why statistics matters in data science? Make sense of data. Instead of then only seeing the numbers, statistics help you grasp what they say. It provides charts, rows, and column with meaning. So instead of seeing the numbers, if suppose in the statistics, they are giving like a graph or table manner. Okay, it is very easiest way to understand the concept. Okay, it makes very sense. Even though each and everybody easily grasping the statistics data compared to the remaining one. Okay, finds useful patterns. It makes patterns and trends in the data visible. Supports smart decisions. Okay, and also statistics supports the smart decisions. Not only things in many fields like business, healthcare, and testing theories. All these things. Next. So reduce risk of mistakes, help explain result clearly, builds a strong foundations. Next one. Yeah. Statistics is the foundation on which data science is built. It provides the essential tool for understanding analyzing and interpreting data, allowing us to uncover hidden patterns, make informed decision and driven innovations. Okay, next. So from the fundamental concept of discrete and inferential statistics to the advanced technique used in machine learning, statistics empowers data scientists to transform raw data into actionable insights. Okay, for that we are applying this statistical technologies into data science. Next. Thank you. Thank you.
Thank you very much for your presentation, madam. It was very nice and more informative. Participants, any queries?
Hello. Good evening. Ma'am, this presentation is too excellent. It is useful. And madam given point to point information. So please, my humble request, if it is possible, then share the PPT yesterday's as well as today's PPT on our WhatsApp group. Thank you, ma'am, for your nice presentation and explanation.
Thank you, ma'am. Thank you. Thank you very much.
It's a truly excellent presentation, ma'am.
Thank you for patient watching. Thank you.
I would like to welcome Ms. Uttara Devi, ma'am, to deliver the vote of thanks.
Pleasure to give a vote of thanks on the special occasion of the ACT ATAL sponsored faculty development program of data drive model empowering academic for data science era. First, I sincerely thank our respected management for the great support and encouragement it's make FTPs possible. I sincerely thank our resource person, Dr. P. J. Gaurima, for her wonderful informative section on mathematics and statistics for data science. Her clear explanation for statistical principle and the importance of maths in data science. The special thanks our head of the Department of Computer Application for continued motivation and guidance. Thank you all faculty member, organizing team and participation. Thank you all for making today's program a great success. Thank you all.
இப்போ அதுல என்ன ஷேர் பண்ணவே இல்லை.
Ma'am? Ma'am?
என்னம்மா?
Yes, ma'am. Hello.
May I leave?
Ma'am?
May I leave?
Hi, Amma.
May I leave, ma?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Thank you very much, ma'am. Thank you, ma'am.
Ma'am, this is today's feedback link, ma'am.
It is shared, sir. Just a minute, sir. Once again, I'll share you.
Yeah, please. I think maybe disconnected in between.
Maybe, sir. Though I'll share you now.
Madam, do you have any other session on this using this maths or like using Python or any other this one? How to use these mathematic fundamentals?
No, sir. Actually, tomorrow we have planned
like data analysis using Python or something. Like today, ma'am gave very good discussion about this mean variance and quartile
yes,
and
sir.
other things. Mathematics for programming purpose or like any machine learning or deep learning applications.
Yes,
we need...
it will be coming, sir. Tomorrow we are going to have the machine learning. Day after tomorrow, TensorFlow.
Okay, ma'am.
And the next day,
today it was very excellent, but completely basics of maths.
Yes,
how to use this for application? Some programming examples, if it is given, it will be useful.
It will be coming in the coming days, sir.
Oh, okay, ma'am. Thank you.
Feedback link is shared in the chat box, sir, and also in the YouTube link also, and the same will be shared in the WhatsApp group also. Please fill the feedback.
Okay. Yes, ma'am. Yes, ma'am. Thank you.
Thank you. Thank you, sir.
Ma'am, share the attendance. Ma'am, please share the attendance link.
Ma'am, it is shared, ma'am. It is shared in this chat box. Chat window, it is shared, ma'am.
Madam, is this chart that is attendance come feedback, madam? That is?
Yes, sir. Both are the same link.
Okay, okay. Yesterday I have not done, madam. Yesterday also you shared, huh?
Yes, sir. We have shared in this Zoom window and also in the YouTube.
Yesterday I forgot to fill, madam.
Okay, sir.
But I attended, but I forgot to fill this.
Okay, sir. Are you in the WhatsApp group?
Yeah. WhatsApp group I am have.
Then you can specify your name down, sir.
Yeah, Tirupati Rao, Singapore.
Okay, sir.
Ma'am,
Yeah,
ma'am, I am also yesterday forgetting.
Okay, sir. I will share the
myself
both
Raja.
the today's as well as the yesterday link in the group, sir.
Okay, madam.
My WhatsApp group or Zoom?
WhatsApp group, sir.
WhatsApp group. Okay, ma'am. Okay.
Today's feedback link is shared in the Zoom window.
Okay.
Yesterday's link will be shared in the group and also today's link. Both the link.
Okay, ma'am. Today link. Today feedback is submitted, ma'am. Yesterday only.
Okay, sir. I'll share the yes, sir. I'll share you.
Okay, ma'am. Thank you. Thank you, ma'am.
Thank you.
Both are feedback link, ma'am.
Yes, ma'am. Both are the same link.
That is enough, ma'am.
Enough, ma'am. Actually, someone asked again, so that only I have
Because
copied.
yesterday we filled the attendance separately and feedback separately, no, ma'am.
No. The same link only yesterday also.
Okay, ma'am. Thank you, ma'am.
Yes, ma'am. Thank you. So thank you very much for your participation, ma'am. Now I'm closing the Zoom meeting. Thank you very much.
And one more doubt, ma'am.
Yes, sir.
For a day, only one link you will send, no, ma'am?
Yes, sir.
Yesterday you sent one link.
Yesterday one link and today
also
one link.
One link.
Yes, sir.
So for per day you are sending only one link.
Yes, sir. Yes, sir. Only one link will be repeated.
I have filled two links, ma'am.
No, I've repeated the same link, sir.
Okay. No, today second day, ma'am.
Yes, sir.
Today,
Today,
yesterday, so yesterday and today's, ma'am.
Yes, sir. In all the days, one link will be shared, sir. For both attendance as well as the
per day one link. Okay.
Yes, sir.
Thank you.
Thank you. Thank you, sir.
Madam, you are sharing the link in the group, na, today?
Today still I didn't share, sir, but I'll share within 10 minutes.
Yesterday's, madam. Yesterday's.
Yesterday link and today link I'll share within 10 minutes, sir.
Okay. Right, madam. Thank you. Can I leave, madam?
Yes, sir, please.
Yeah, thank you.
Ma'am, good evening. This is Mohana.
Yes, ma'am.
Ma'am, I just want to congratulate you, ma'am. I'm Mohana from former staff of SR, Nara Saraswati College. Now I'm working in Coimbatore in Sarkis.
Okay. Thank you very much, ma'am. Yes, ma'am.
Congratulations, ma'am, for your wonderful job.
Thank you.
Very useful for this session. Thank you so much.
Thank you, ma'am. Thank you very much, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you, ma'am.